even though we've worked with exponential growth and decay, there is also continuous growth or decay, which is using an exponent, but this is like a special case of it. So when we're looking at just a general exponential function, it's in the form of f of x equals a times b to the power of x, where a is our initial amount, b is our growth factor, growth factor or decay factor. Well, if it's continuous, we actually know what the growth factor is. So for a continuous function, this is E. Now, some of you might be thinking, what is E? E is 2.7182818828, and I could keep going on. It's similar to pi in the fact that it's irrational, and this can be derived from the sequence of 1 plus 1 over n to the power of n. So 1 plus 1 over n to the power of n approaches a limit of E, which is 2.718. We'll just leave it right there. So, like I said, E is similar to pi, in which it's a special number that we have a new notation for. Why is it denoted with an E, you might ask? Well, Euler was the one that found the sequence and where it approaches. So I'm guessing here, so don't quote me on this, but I'm assuming that it's because Euler starts with an E, and that's where we're going towards. So what applications does this have for me? Remember when we were working with money and compounding it daily and all of this other stuff? Well, we can actually compound money and interest continuously, and we use E. So compounded interest, and this is continuously. So we're going back to our money situation. So before it was in the form of A equals P 1 plus R to the power of RT. Well, we still have that information. Our 1 plus R, though, gets changed out with our continuous factor of E. So this was before compounded annually or whatever it is, you know, if you're compounding daily or whatnot. So in our case, though, this is compounded continuously because we have the E. And that's our growth factor. A still represents the initial or the after dollar amount. P is still our principal or our initial. R is our rate. And T is our time in years. So for instance, how much is left in an account? Missed a C there. If Shelley deposited $500 at 3% after 4 years. So we've done this type of information before, so this should be old hat. You just plug in your information you know, and then just type it right into your calculator. So we know it's going to be, oh, sorry, I forgot to tell you, this is compounded continuously. You kind of assume that anyway, since this is what this section's about. All right, so we've got A equals PERT. A equals, our initial deposit was 500. We got the E there. R is 0.03, T is 4. Now, some of you might be wondering, where is the E button? If you are on, well, I should say most calculators, it is in the bottom left side, and it'll be somewhere within that little corner on the bottom left. Some of you might have to do a shift and then to get your E. Some of you might not. It just depends on your specific type of calculator. But otherwise, you can just plug this right into your calculator in order to calculate this. Make sure when you're doing the exponent that you have all of the 0.03 times 4 in the exponent spot. Some people get goofed up with this. If I were to plug this in, I get $563.75 after 4 years. So even though it's compounded continuously, that's really not a whole lot of difference after 4 years. It's only $63.75. That's really not that much. But you got to think about it. You're doing this at 3%. You're not adding money to it. You're not deposit or withdrawing money either. So it's not like there's a whole lot going on there. You could do the reverse of this. We've done that before. I'm not too worried about that. Otherwise, this is how we use our E button to represent a continuous growth factor or decay factor.